Welcome to today's demo. Today I'm going to talk about the AI software factory, not as a coding tool, but as an executive level architecture pattern for overseeing and optimizing software delivery. My name is Jeffrey Palermo, and I am the Chief Technology Officer of ClearMeasure, a full service software architecture and engineering firm delivering custom software solutions using AI, Azure, and everything that the .NET ecosystem has to offer for our clients. And even though the world of AI transformation and software engineering is still new, there's a lot that is new and a lot that is changing about the process by which we deliver software. And so the AI software factory, the mindset is about orchestrating how software moves through an organization so that we can systematically increase throughput while keeping quality high and using every one of the tools and frameworks and available technologies that is coming out from Microsoft and OpenAI and Anthropic and GitHub and everybody that is building great technology for our industry. All right. So um, let me give you just I have two main demos, and let me give you the context for the first one. So for for decades, software delivery has been the constraint, and it's still the constraint. Demand for change is it's only going up. The team size is mostly fixed. We tend to create teams and then have the teams deliver. And delivery throughput typically lags what the businesses need. They're always asking, when is it going to be done? And the promise of AI is continuing to be in the future, you'll be able to. In the future, you'll be able to. As much as it's being talked about, um, it's still very much in the marketing and but it continues to elude many. So um, every software organization wants more software delivered faster, and and really that's where we're aiming at. But there's some constraints there. All right. Most of these organizations, if they try just to quote go faster, it doesn't work. Throughput is not something that we can directly command. It's really what remains after defects and instability stop stealing the team's capacity. And AI can't just automatically do anything on its own. I mean, it's a robot, it's a computer. It can't do anything on its own, much less give perfect work consistently all the time. And so there's some prerequisites that we have to have. There's three categories of delivery metrics, some things that we need to measure that are prerequisites. Quality and stability, two of them, those are not nice to haves. They are prerequisites. If defects or production incidents consume the time and attention of our team, well, then there's no capacity left for throughput. No matter how much automation we add, it doesn't work. And unengineered AI adoption can really make delivering defects into production happen just much quicker. And that's not what we want. Okay. All right. The dynamics of our industry really aren't changing. The technology, man, and the AI transformation, boy, is that changing. But the dynamics, they're really not changing. There are quite a few um, theories and breakthrough and works that have come in decades past that have listed the books on the screen, and we're continuing to build on those. The Gold by Eliyahu Goldratt, that is a mainstay in business executive MBA curriculum, and in that book was defined the concept of the theory of constraints, and that continue any kind of empirical process or any kind of workflow where you have input on one side of the workflow and you have output on the other side of the workflow. There are constraints in the middle. There are bottlenecks that move around, and all of the work afterwards, it kind of builds on that. And then there's systems thinking, there's quality management, there's flow and waste elimination from the Toyota production system. and then of course lean manufacturing. There's so many other books that are related to software that have the previous four books in their bibliography. And so I wanted to bring those up because we are effectively we are putting together a complex workflow where there's a lot of stations of work that have to be strung together, and some of them happen in parallel and some of them happen in series, and that's what we're putting together. And with AI, with the advances in AI technology, yes, we're going to automate quite a bit of stuff, but overall we still have to orchestrate a high level workflow in order to get value delivered to our business, right? So I wanted to kind of just frame your brain with that type of thinking. Okay, so we have orchestration patterns everywhere. And we kind of already accept orchestration patterns in many different places of software delivery. We have the continuous integration build, or that's build orchestration. We have automated deployments, and that's release orchestration. We have Scrum sprints or iterations, or even daily Kanban cycles. That's the team delivery orchestrations. And so now, what I'm proposing, this AI software factory pattern, I'm proposing that you think about it as an end-to-end delivery orchestration. Think, what is my highest level overall delivery, software delivery orchestration? And so that's the umbrella layer over the top of it. And I actually don't care what you call it. There's nothing magic about the words AI software factory, but you need to have an overall orchestration strategy. And uh, an AI software factory is not a single tool. It's not just AI coding. It's a system that orchestrates people, processes, and automation. And this is critical. The AI software factory is about building a system where automation does the repetitive work and engineers focus on engineering. Okay. Now, I talked about prerequisites. This here is our AI DevOps architecture poster, and you can go to our website and you can request a, a high resolution copy of our poster. This is only actually the top third of our AI DevOps architecture poster, and there's a link to it in the chat as well. And basically, it gives you the skeleton for some of the things that you really have to have in your team's software engineering environment, your DevOps environment, so that you can enable the adoption of AI automation. All right. Um, so I wanted to touch on that. Now let's get to the first demo. I just want to kind of show you real quick um, how to think about automation. I just have a demo and I'm running it straight here from Visual Studio. And I'm going to pull that over so you can see. Okay, Visual Studio, pull it over. There's a there's a Visual Studio solution that I'm running. None of these files really, but I'm running against a Bootcamp GitHub repository, and I'm actually going to show you where this is because you might want to get the sample code. Again, it's just sample code, and it is Clear Measure Labs AI Software Factory. Okay, we'll put that in the chat as well. And put that to everyone. Okay, great. And that's in the chat. Now, there's nothing magic. This is not a product. It's not a software as a solution product. And there's a lot of documentation and architecture diagrams so you can see how it's put together. But it is a sample. It's an orchestration sample. Okay. And so I have run it from Visual Studio. And of course, it pops up in Aspire application. And I'm going to go to the web dashboard. All right. In the web dashboard, I can kind of operate some things, and I am operating on a let's call it our boot camp or training application, and our training application is really it's right here. It's deployed to Azure, and you can actually see the URL right here, and you can see it is a work order application for the First Church of Springfield. I can log in as Timothy Lovejoy. oops, Timothy Lovejoy, portal, and I can create a new work order. I can um, search for a new work order or look at the work orders that I have created. I have asked groundskeeper Willie to do some lawn maintenance. Um, and there it is. I have a little AI chatbot. Okay, so there's nothing magical about that. But if I go to health check detailed, I can see, I'll put that in the chat as well. If anybody wants to follow along. I can see it's healthy, um, but I am going to corrupt the memory. I'm going to, where's that? Right here. Set to unhealthy. Okay. And if I refresh, I can see now I'm unhealthy, memory is corrupted, restart the process. We all have these situations where something happens and it's a production issue, and I just need to kick the server or restart some process. I don't actually need to make a code change. I need to just restart the process. So over here, I have a totally empty Kanban board, which is not normal for a project. But over on the right, you can see that dynamically a issue has been created, production incident unhealthy needs reboot. And so if I open it up, and you can see now is when, no, I didn't mean to click on that. But you can see that there's comment now. AI Factory cursor has been matched for work order. So we have cursor as well as Copilot and Claude and Codex. But cursor has been matched for this work item. And now we see that the agent session has been created in cursor and the production incident resolution. Okay, it's healthy. The application has been verified healthy after remediation. And we are done. Okay, so this claims that it took care of the issue. So if we go back over here and hit refresh, F5, yep, healthy. It's now healthy again. And if we go back to the application, yep, it's ready to be used. Okay, so we have some AI automation that just happened in the background that automatically took care of something. And we can see that the work order is closed and it was moved over to the done column. Now, if I just do that again, just for illustration, I'm going to set us as unhealthy again, go to my Kanban board, and within a few seconds, it's detecting based on the health check, and it should pop up another production incident and then start working on it. Okay. And if uh, I have to hit refresh on this board, or did I? It is unhealthy. Okay, it might take a minute, but let me click on. Oh, there it goes. All right, so it's working on it again. But let me take the finished one, and the finished one, it gives me a link to the cursor session. So I'm going to cursor.com, and this is a cloud agent session. And of course, this is the prompt for what to do. And it took 34 seconds for a cursor agent to execute the prompt and see that there was a production incident. Here's the URL, and yeah, I'm just using it's deployed to Azure. I don't have custom DNS, and that's basically it. Okay, so I'm in cursor, and that's the same thing as calling, fix my bug. And so instead of doing this manually, I am programmatically using the Cursor SDK to create this agent session, and then I am creating comments so that I'm journaling what it's doing. And that can be done with any of these technology, the Copilot SDK. All of them are getting better, so it doesn't matter that I happen to use Cursor in this demo. All right, so what I'm also going to do is I'm going to create a lot of work items, and you'll see them popping up in conceptual definition. We're going to create a few, and you can see in our Kanban board, we have a lot of statuses, right? We have a lot of columns. Development is in the center, and to the left of development tends to be the things that we do to think about work, to design work, and to do some technical design, some test design, and get ready for actually writing the code, get ready to actually do development. The things to the right of the development column tend to be the things we do to validate that the code is good enough to send to the customer. And so we tend to have a mirrored situation around development. All right, so our new work items are coming through, and add work order instructions. I'm going to take one of these, make the login button blink, obviously. Actually, I'm going to, no, I'm gonna the navigate hide button. All right, I'm gonna take this one, and I'm gonna take this off of demo mode, and I'm gonna queue it up for the AI software factory and just let that go. And um, and then I'm going to label the rest of the issues. Okay, so add navigation hide button. What what I want this to do is, because I've labeled it for the AI factory and auto merge, I want this to be picked up automatically. And we can see already that cursor has been matched for this work item in the status UX design, creating an agent session. And we can see that the UX design session has already been created. We can click over it, and now we have a cursor session where it's fetching the work item from GitHub and looking at all of the text there, and then it's starting to read our code. It's already checked out our code, so now there's a code session. All right, and so if we go back here, this will take a bit, but what we want is for all of this AI automation to be dispatched wherever it needs to go, and we want to ask ourselves, okay, is there any of the work for UX design that can be done by an AI bot? Is there any of the technical design that can be done automatically? Is there any test design that can be done automatically? Is there coding, there development that can be done automatically? Any functional testing, UX testing? From all of the work that needs to be done, we already showed that certain types of production incidents can be resolved automatically. So what we're looking at here in our workflow is we're mapping out our end-to-end workflow, and we're saying, okay, what can be delegated to the computer? So a lot of the work needs my own brain. It needs creativity, and no, if I just give it to an AI bot, it's not going to happen the way it needs to. I clearly need to think through some of the things that require engineering. But for the work that doesn't require engineering, but merely just requires a little bit of work and it can be delegated to the computer, that's what we want to delegate to the computer. We want to plug in these AI tools where they can actually do those tasks. And sometimes it's not figuring out what to do. Sometimes it's going around and gathering logs or gathering information and pulling it all into one place and augmenting the work item. Let's see, navigate. Is this the one we picked? Yes. Okay. So this is the one that automatically was worked on. So if I scroll down to the bottom, we can see that the session was created, UX design is complete, and here is the summary for user experience design. And now at the bottom, it's being picked up for technical design. Now, we didn't write any code, but what did we do? We took we took the concept, because this was all the information that was in there, and we looked at all the documentation, we looked at the entire code base, and we were able to harvest out of the documents that we already had, out of the architectural diagrams that we already had, out of the wireframes and UX guidance that we already had, and we were able to harvest some likely direction for user experience design. And as you read through, you can see that. And it looks like technical design has already been finished. Same thing. We're adding to the body what the technical design should be. Now, this is an easy work item. Add navigation hide button. In other words, a button so that I can hide and re-enable the navigation. That's not hard to do. Anybody on the team can do it. And in order to make it so that we can just delegate it to the computer, we've kind of already learned that all of these language models really do well when you have a plan implement type of workflow. And the plan implement is the plan ends up being the very detailed spec or the very detailed prompt for writing the code. And so what we're able to do as we go through our normal cycle is, well, I've got this part of the plan, technical design. It literally identifies lines of files that are already there. And so now I have a technical part of the plan. You can see the, main layout, nav, JS, that needs to be a new file, patterns and conventions to follow. This is coming right out of our documentation. Okay. Even acceptance tests. We're using Playwright with acceptance tests using a acceptance test base class. Um, all right. So we have all that. Oh, and test design just popped up. All right. So what kinds of tests do we need to create? Well, we have some integration tests that we need to create. We have an acceptance test or end-to-end test that we need to create. So look, we have one test, two test, three test, four test, five tests, and then some test data. And so taking all of this, we have a pretty good plan. And now the code to be written, that's any of these AI tools can do it. And we did it just by taking every time that it moved through a status, we take that and delegate to an agent, and then we augment the body of the work item. And of course, all along the way, we are journaling what we did. All right. So to development. Oh, and it looks like now development is going to happen. And yep, it's over in the development column. Okay. So we have a very good spec effectively in the body of this work item because we have built it up incrementally. And while at the same time, we can do that in parallel and we can have lots and lots of work items being worked on and moved through. And there's always going to be things that can easily be delegated to anybody on the team because it doesn't require engineering. It only requires a little bit of analysis and a little bit of programming, easy stuff. And so we want to take that easy stuff and delegate it to the computer while we reserve the things that do require creativity and do require engineering. We reserve our team's capacity to actually work on those things and not be distracted by the work that really is just child's play. Okay. So in this particular sample, we use the labels AI Factory, whereas if you look at these other ones, they have a demo label where we're kind of just showing, but we're not pausing on them. All right. So let me while this is going, by the way, just to show you in parallel, if I hose the environment again and make it unhealthy, then we'll see that we can, watch production and fix production incidents that are compatible with AI automation. And that just pops up in the release queue. Okay, let me go back to the slides, and that's the first demo. And then I'll do demo number two. And as anyone has any questions, you can put that in the Q&A window, and we'll get to it. Okay, so let's do that. Okay, so there's three capabilities that matter when you're putting together your own AI software factory. And the uh, first one is clarity. You want to have end-to-end visibility. The second one is the ability to change and improve the workflow. And third is the ability to forecast. Everything that follows kind of hinges on these capabilities. Without visibility, we're guessing. And without the ability to change the workflow, visibility really doesn't matter. And without the ability to forecast, we can't tell our customers when it's going to be done, or what would make us go faster or what's slowing us down. And if I raise it up even further, in order to answer those whole questions, I want to think about what I have, and I want to think about how things are going. What I have and how's it going. All right. What I have is the architecture of the whole piece of software and how much of it and what's connected to what and how does it work. And then how's it going is how fast am I going? How many bugs do I get? How many production incidents do I get? How many are easy? How many are take the whole business down? That's under the phase of how's it going. Um, and most teams, when thinking about this, only see fragments of the process. Product management might focus on the front end, development teams sit in the middle, then ops and customer support focus on the live site. the AI software factory pattern treats software delivery as a single system with multiple stations of work. Each of the stations of work, we name that status and we understand the nature of the work that has to be done in order to move it forward. And when we find we can't move it forward because we missed something, well, then that work moves backwards. And the Kanban board is really a good pattern, but this work tracking board that we put together, it has to be comprehensive. And again, I mean, there's so many project management tools that have a digital work tracking board. That's not rocket science, but actually modeling your workflow and making sure that you have a column for every station of work that is important in your workflow, you have to do it. All right. You have to do it. Now, I want to hammer on just one point on visibility before we move on. Why visibility is non-negotiable. Uh, Executives of your business would not run finance without financial statements or a weekly cash flow forecast or having a quarterly and annual budget. Running software delivery without visibility it's really the same mistake. But because no commercial tool out there just does this automatically, we have to put it in place intentionally. And so forecasting into future releases and future projects is a capability that we will only gain by putting in place the measurement of what's actually happening. What do we have and how's it going? That enables us to project into the future. What can we do? All right. That uses the same manner of measuring actuals and tuning them. And then we can project into the future, either assuming that things don't change or forecasting what would happen if we change one or our metrics. All right. So let's go to the second demo. All right. If I bring over, let's see here, this. All right. Our, we're still working on those things. If I bring over this right here. Okay. I think I have the right. Yeah. Here's a all right, here's a scorecard. All right. Now, we're just gonna kind of simulate some things. And I'm going to run a simulation grouped by week, and we're going to simulate 60 days of work. We're going to simulate a team working 60 days of work, and I'm going to show you, week 14, 15, 16. Okay. And we're going to simulate 10 developers working 8 hours a day, and with one product manager. And every day that product manager is coming up with a new feature. And we have some complex feature requests. And typically, when you have a complex feature request, you don't work it as a whole because it's too big, right? But you break it out. And complex features, it's very normal for complex features to be broken out into 10 smaller things. That happens all the time. And then there's a simple request where it comes through and it doesn't need much analysis because it's simple. And the simple things, the AI tools can just do them in one shot. You just do a little bit of plan, a little bit of spec, and then they're done. The complex requests, those typically require creative engineering. Those typically require us to really think about and make some decisions and then break them up into their individual simple pieces. And once we have the individual simple pieces, each of those simple pieces tends to be suitable for AI, whether in whole or in significant part. And so we have simulated 60 days and we have metrics. Okay. And if I scroll up to the top, we have 207 features that we've created. There was 31 bugs and 25 production incidents. And so we have three categories of metrics, which I actually don't care how you put this together. You need to have uh, these categories of metrics for your team. And throughput is the first category, quality is the second category, stability is the third category. And so by week, let's just look at the most recent week here. 18 new work items came through. And then progress is where a work item moves forward one column. Rework is where one of those work items moves backwards on the board. Somewhere on the board, it moved backwards. And then net progress is forward movements minus backward movements. And you can see we've got quite a few backwards movements. So we have quite a few implicit defects. We caught them before getting to the customer. That's good. But we still had situations where we thought we had taken a good step forward, but we accidentally took a step back. And then throughput here are items that actually were delivered to the customer. And then mean time to delivery in number of weeks, it took us about two thirds of a week. And if we average over the last 4 periods, the average mean time to delivery is 1.82 weeks. Okay. And then work in progress, our average is 63 now over the last 4 weeks, 63 work items in progress. Now, if you have a team of 63 people, maybe that's okay. But if you have a team of 10 people, well, that's 6 things in progress per person on average. That's not okay. Quality are the things that steal delivery, steal throughput capacity from our team. If quality was a lot better, our throughput would be better. And we can see that, we have every week we have a new defect that escapes to production, and meantime to resolution, it's taking us about half a week to resolve it. Same thing with production issues. On average, we're taking about 2.5 to 3 production incidents that happen per week. Mean time to resolution average is 0.45. All right, we are going to forecast into the future, and I have my forecasting tool that I'm just going to show you, and this is where you can run simulations uh, from your current metrics. And what I'm going to do is I'm going to say, you know what, let's do some things to fix our quality, and let's fix our quality, and improve that by half. Let's get down to one production issue per week. Let's fix that. Then let's implement some AI automation just for the simple things. Let's get some these simple things deployed with some AI automation and development for the simple things, darn near 100% these days. Functional, halfway, UX testing a little bit because we still have set eyeballs on it. Release queue to make sure we have logging. That's pretty high up there. And let me forecast into the future. So I'm going to start this, and as this runs, we're actually going to add on to our scorecard. And I want you to see mean time to delivery was 1.5, throughput was 25, average over 4 weeks. And you can see as we do 1 week, and I know this is fast forwarding, we do 1 week and then we do a second week. You can see our mean time to delivery is now less than a week, and our throughput was in the teens, and now it's up to 40 items per week, 42, and now we're into 4 weeks. And mean time to delivery, we're now less than 2 days, 2 days mean time to delivery, and now 41 items. Why? Because look at our quality and look at our stability. We're just we are reducing the activities that steal the capacity from our team. And now, when product management asks for a particular item, on average, we can deliver a new simple feature request in about 2 business days. That's our average for this particular team. And this is important because you need to be able to say these things to product management. On average, when you request something that we can, hold in our hand and grasp, and we can when it's simple, when we understand what that thing is, then 2 business days. On average, that's what it takes. Now, the big things that we don't quite understand, we got to do some work on. We got to do some creative analysis because we have to break it up into its parts, where each of the parts becomes a simple thing where, okay, it's bounded. We know exactly what it is. And once we know exactly what it is, 2 business days. All right. So you need to know these numbers, because when we work with clients, typically, typically the teams don't understand how much capacity, how much time from the team is being stolen because defects are escaping out of the process, or how much time is being stolen because production incidents are happening and they're getting escalated right to the engineering team. All right, so that's simulated, but uh, let me go to a real project that is not simulated. So I'm actually going to uh, set as a startup project here, and I'm going to close the other one. Control F5. And this is actually going to connect to the Azure DevOps board of a real client project. And we have permission to uh, show this. Let's see here. Okay, hold on a second. I need to re-enter the key. Be right back. Copy and paste off screen. 1 second, and that will be happy now. Okay, running and it's healthy. All right, so let me open this up. And okay, we have the scorecard. I'm going to go over to the simulator. We're just going to clear the old data. Clear all data. There we go. All right, and I'm going to go to a custom range. And this project happened uh, in mid 2020 to 2022. Okay, so that's the range that we're gonna harvest this. We're gonna pull down all of the work items in that range and all of the work item revisions from an Azure DevOps project. And by the way, all of these project management systems have APIs. It's not rocket science. I mean, GitHub projects, Jira, Azure boards, Zoho projects, Zoho sprints, they all have these APIs where you can just kind of pull in. It's easy, right? It really is. You don't need to know the syntax. I mean, if there was anything to AI vibe code, it would be just twiddling on the API of these systems just to pull down some data. Okay, so we're pulling it down, and we're about halfway done, and it's going to show us our scorecard that we can analyze. And if I just show you real briefly, here's the Azure boards. And this project kind of stopped in 2020. And so you'll see a dynamic in 2020 how from development, we have a whole bunch of empty columns, right? A whole bunch of empty columns. And then we had some things in development because this was a point in time project for county fairs doing junior livestock auctions when the county fairgrounds would not let people physically on. So it was a online auction simulator system. And so in mid 2025, just like websites of political campaigns, once the election is over, that system kind of goes away. That website goes away. So same thing with this. It ran for 2 years, and then in mid 2022, okay, it was over. So basically, the project was abandoned, and we didn't need to do these additional enhancements. And so that's the nature of this board. Just so you know. All right. So if we come back to there we go. We have 1,135 features that were pulled out. And by convention, this particular project used a tag of quote bug to specify bugs. And we're going to group it by month. And so we can see 2020 all the way to 2022. So this is by month. And we can see, if we go back in time, we can see it wasn't until August that we really started having some defects that escaped per month. And we really didn't have a whole lot of escape defects. It's actually a very good project, um, except some of the mean time to recovery. That is skewed because obviously it was skewed because the projects were abandoned and just things were left. All right. Same thing with work in progress. If you leave things on your board, it's going to skew your numbers. But I brought this up just to show you some of the integration that you need to build for yourself. Production issues were not tracked in Azure DevOps, and so those are all zeros. But if we look at if we look at some of these defects that escaped, and we can click on here and we can see, oh, the bugs, we can click on the link and we can go right over to Azure Boards and we can see whatever the bug was. Okay. And also, let's see rework. So that can be a little bit confusing because we can say, well, this particular item we had a lot of, let's see, we had a lot of rework, let's see, 25, in the middle of 2021. So we had 21 issues that had rework, right? Well, uh, we had technical design test design move to technical design, and we can click and we can go see what happened with that. We can actually corroborate that by looking at the history of the column changes, and we can look through. I mean, there's a lot that goes on with this stuff, right? Okay, so also there are some anomaly detections that you'll probably want to add on to your data. For example, rework hotspots. Well, there's a number of work items that if they never get finished, but they continue to move back and forth, back and forth, back and forth, then um, that's a problem. So let me just open up the history of one of them, and you can see that work item 25928, which is about the spotter tool, an auctioneer, they have a spotter helper to figure out who bid on an item. We can see that it went from backlog to test design to development to done. Oh, wait, no, to functional validation, then to done. Oh, back to functional validation, and then to user experience validation, and then to done, and then ready for release, and then to done. I mean that's a lot of chaos. So if we look at another one, um, we can see that this one happened over the course of a month, the 13th of May from 2020 to the 15th of June. So you'll have every one of us has these work items that really it comes down to a lack of clarity about the environment or a lack of clarity about how to implement something. And so we think that we're taking steps forward, but we're mistaken and we have to do rework. And so this kind of shines a light on the things that are stealing capacity and preventing you from going faster. Now, I'm harping on this because without this, you have no idea where to apply these AI tools. Okay. Because you don't actually have uh, any capability to know if an improvement hypothesis is going to pan out. Because these are all hypotheses, they're all scientific method. I think, if I put cursor in this part of my workflow, or if I put Copilot, or if I put Claude, or if I put Copilot SDK with Squad, um, or if I use an AI Foundry agent, or if I get one of the new Surface RTX Spark devices and have it constantly run some automated agents with the new Windows WSL OpenClaw integration that was announced today at Build, if I put that somewhere, it's going to help me go faster. Well, that's a hypothesis. How do we know? We have to measure, okay? Because we need we need the finance departments of our companies to invest a good amount of money in these AI tools and the AI token spend. And so we need to be able to see what the return on investment that we're getting. All right, so that's the second demo. In order to implement AI in any part of your workflow, you need to orchestrate the whole thing and you need to measure what you have. All right. Um, Now, there's one other part before I finish with this second demo. There's one other part that I mentioned, and uh, that is understanding what you have. And so I mentioned you need to understand what you have, and you need to understand how it's going, and you need to understand what you can do in the future, what you can commit to in the future. So let's focus on what I have. That scorecard, by the way, is all about how's it going? How's it going? The forecast capability is what can you do? A springboard off of how's it going? And so now let me show you just one tool that can help answer the question, what do I have? All right. And so uh, one of the things that you'll probably want to build into your AI software factory dashboard, wherever you put it, is is things to answer the question, what do I have? And one of these things is just an inventory. How many software systems do you have? For a particular software system, how many things get deployed? How many databases? How many web applications? What is the runtime architecture? What is the solution architecture? What is the data flow through the system? And so having architecture diagrams, it's not a new concept, but so many of our clients, they do have some, they're woefully out of date. And this is one thing in the world of these AI tools, there's really no reason anymore to have an out of date architecture diagram. Why? Because the code is the definition of the shape of the software system, and all it takes is a prompt to generate a to generate a architecture diagram from the literal code. And so for this AI software factory, demo code that I have here, well, this is a C4 template of a plant UML diagram, and you can see that this it's a O1 system context dot pummel PUML, and then we're just using the GraphViz library to render it as a PNG file, and then here's the container view. We can see that .NET Aspire is kind of a container. Then the logical solution. These are all the projects in Visual Studio and the references. And then this is runtime. This is actual processes, how many processes are running. Now, I'm not going to pause to help you understand, but there's the workflow. And then you scroll down, there is, I want to go to one of these, yes, the flow. Then you have the data flow and what happens first, second, third, a sequence diagram. And then what about the scorecard drill down? Well, there's the sequence diagram for there. So all of these architecture diagrams of what do we have and how does it work now? Because oftentimes we want to enhance the system and we want to make it do something that it currently doesn't do. That means that we have to transition the design. We have to enhance the design so that we come up with a design that's different from the design we have now. And that means that we need to understand the design that we have now, because when we're finished with that enhancement, it's going to have a different design. Okay. So this is one of the ways that you can answer the question for yourself. What do I currently have? And then, of course, the scorecard gives you the answer to the question, how's it going? How's the project going? And then the forecasting capability lets you answer the question, what can I do? What can I commit to? And what can we accomplish as a team going forward? Okay, we'll finish this out. All right, so step one, again, step one is not AI. You're probably wondering, when I was talking about scorecard, what makes this AI? Step one is the orchestration. It's the Kanban board. You need a complete observable workflow before automation can help. And the scorecard becomes the executive dashboard for software delivery. It tells you whether changes that you're making to the process, it tells you whether the adoption of AI and where you're putting it actually improves outcomes. And then of course we layer on AI. Without the structure of the software factory orchestration, the AI implementation, well, it's going to be manual and haphazard. You're guessing. The question is not, can AI do something? The question is the type of work I'm thinking about, is this type of work stable and predictable enough to automate safely? By analyzing the work at each of the stations that we have on our Kanban board, we can identify the segment of that work that is suitable for artificial intelligence automation. The AI tools now, they provide a wealth of automation possibilities, and it's only getting better. And the AI software factory pattern, it gives us a way to think where we can plug them in, and we're going to guess where they might fit, where we should plug them in, but then we're going to measure the results to know that we were right. And the more work and the parts of the work that we automate through AI, the more of our team's capacity we reserve for the work that truly requires creative business analysis, actual engineering, and higher order levels of thinking and awareness that really can't come from a machine. So automation is not inherently good or bad. It's a hypothesis. And if it doesn't improve the scorecard, then it's not helping, no matter how impressive it looks. And we certainly don't want to spend and not get any value. So to get started with this, start with the easy wins. These are changes that merely require programming, not engineering. This is where you can achieve really near 100% unattended flow. You take the easy stuff and you can craft a little automation that's 100% unattended. There's so many of these tools that are coming out, and it's not going to stop, where you can have unattended agents doing little bits of automation. Start with the easy stuff. And um, and then you'll improve from there, because the easy stuff, they still consume real team capacity today. If when your team has to, fix a spelling change or some stupid little, oh, align that to the left instead of align it to the right, or oh, that container needs to be restarted. Oh yeah, that happens once a month. Go and restart the container. That's easy stuff. Anybody on the team can do it. But if we have somebody on the team do it, that still consumes real team capacity. The AI software factory removes that load entirely, and then you can see it reflected in the throughput metrics on your scorecard. So um, we want to leverage compounding improvement. We want to climb the maturity curve. The engineers, us engineers and architects, we we are building a, I would say, in decades past, we built the code, and we built source control, and we built continuous integration, then we built automated deployments, and then telemetry. Well, then we kind of built an entire DevOps environment. Now we're raising up. Now we're building a figurative entire software factory powered by AI. So we are building this factory in a way that creates more opportunities for automation and more opportunities for our team to stay in a good world of creativity, and improving that over time. All right. Um, we all know that AI accelerates everything, including failure. Anything that I know how to do, the computer can help me do it faster. Any mistakes that I'm on the way to make, well, the computer just helps me do it faster. These are fundamentals. Um, and without good fundamentals, the automation is just going to deliver bugs faster. So we don't want to do that. Um, and so, as a reminder, the strategic impact of the AI software factory pattern is at the executive level. This is leadership infrastructure. It gives executives real control over software delivery. If you are running a team, then you are going to empower whatever executive has oversight, accountability over your team, and you're really going to be helping to serve that leader in a really good way. If you are a CTO or an executive that oversees a software team, then this is what you need in order to really be able to answer the questions: what do I have? How's it going? And what can I do going into the future? You'll remove a lot of the guesswork. So where does ClearMeasure fit in? We don't sell AI tools. We implement them and help organizations build delivery systems that can safely exploit AI without destabilizing the business. And so we are scheduling AI strategy sessions all the time, helping custom software delivery teams implement AI and do a better job with software solution builds. We also deliver full software systems and run them. Um, and so, um, and so if you would like to schedule a complimentary AI strategy session, you can do that now. You can sign up using the QR code. You can forward this to anyone in your organization, and and we would look forward to getting to know you and have a chat with you. So Thank you all for your time. I appreciate it. If any of your colleagues missed this webinar, um, you can request a recording of this. We'd be happy to send your colleagues a recording of this AI Software Factory demo. And God bless and have a great day.